Everyone. I hope everyone's doing great. So, in today's lab, we'll do a lab by Cyberdefenders called the Tomcat Takeover Lab. And this lab will assess our skills in network forensics, where we'll be given a packet capture and we will analyze it. Okay. So, let's start by reading the scenario. So, the scenario says the SOC team has identified suspicious activity on a web server within the company intranet. To better understand the situation, they have captured network traffic for analysis. The pickup file may contain evidence of malicious activities that led to the compromise of Apache Tomcat web server. Your task is to analyze the pickup file to understand the scope of the attack. Alright, so I already did the lab, but let's do it together. First of all, you have to download the lab file and extract the password. I already did it, and as you can see, this is the packet capture for the file. And so let's start analyzing the file. So question number one says, given the suspicious activity detected on the web server, the pickup file reveals a series of requests across various ports, indicating the potential scanning behavior. Can you identify the source IP address responsible for initiating this request on our server? Okay, so when it comes to scanning, what you can do to find the IP is first of all go to statistics and conversation to see the communication between the IPs. And from the first spot, what you can see is that there's a large number of packets all coming from this IP 14.0.0.120, which is actually a public IP compared to the others 10.0.0. So what you can see, yeah, so it's sending request a lot of packets to this IP. So we can assume that this is the IP address originating the scan. But in order to double check, we can um, apply this as a filter. All right, and we can go here and we can see with what kind of scan is it, or is it originating scan? As you can see, this is the source and this is the destination, and as you can see here, the port that's being used. Sorry, a destination port. We have, several ports, and if you move down, as you can see, uh, let's look for yeah. As you can see, this is the source destination, and you can see here a large number of sync packet, which is indicative of port activity. And if we look at the destination port, we can see several ports. So we can say for sure this is a scanning activity, and it's a SYN scan because you can see it's sending a SYN packet. So this is the source IP 14.0.0.120. So we have answered this question correctly. Question number two says, based on the identified IP address associated with the attacker, can you identify the country from which the attacker activities originated? So we just can copy the IP and go to any threat intelligence website, let's say geolocation IP address lookup, paste and see where this IP is originating from. And as you can see, it's originating from China, from a region or city called Guangdong. The region Guangdong. Okay, so it's since they're asking for the city or the country, sorry, it has to be China. Okay. Question number three. From the pickup file, multiple open ports were detected as a result of attacker active scan. Which of these ports provided access to the web server admin panel? Okay, so what we can do since there's a web server admin panel, we can look for HTTP communication. So we have the same filter and just add and HTTP. Let's copy it for okay. And as you can see here, this is the source, this is the destination. There's some sort of communication. All right. So um no, so this is an HTTP. As you can see, we have here some 200 response code. Okay, if you scroll down, we have some 400 also, 400 not found. But if you look at this, like if you look at those 200 requests, you can see the port is 80, 80, 80, 80, HTTP, HTTP, HTTP. The port is actually 80. Even if you look at the response code of 404, So yeah, so I would say it's communicating with the port 8080. All right, source port 8080. So yeah, so it's 8080. That's the port. Yeah, it's 8080. We can also like go to one packet and see just one quick. If you go to here, for example, follow TCP stream, as you can see, yeah, 8080. The host, and this is 8080. Anyways, let's return to the questions. Question number 4 says, following the discovery of open ports on our server, it appears that the first attacker attempted to enumerate and uncover directories and files on our web server. Which tools can you identify from to analyze this to assist the attack in enumeration a process? All right. So what attackers usually do is that they enumerate the website to or the server to identify any kind of secret directories like the admin panel or any kind of privileged panel. So um since it's enumeration, we can expect of course some response code like 404. The page has not been found because the tool is trying different names, right? Admin, administrator, whatever. So what they're asking for is actually the tool. Okay, so we can go just to anyone, to any 404 for instance. We can follow the TCP stream, and as you can see from the user agent here that the attacker is using, this is the client. The red is the client, and the blue one is the server side. So you can see he's using GoBuster. And for those who don't know, GoBuster is like yeah, it's a tool used for enumerating directories in a website, web servers, etc. So that's the tool he has been using. Just return to the okay. So it's GoBuster. Okay. Question number 5 says after the effort to enumerate directories on a web server, the attacker made numerous requests to identify administrative interface. Which specific directory related to the admin panel did the attacker uncover? So the tool has discovered a page or directory related to administrative privilege. So we have to know the name of that page. So we can just go scroll down and look for specially 200 response codes. All right. So as you can see, we can have here 100 response code get slash manager HTML. If you go also above, you know, at first it was unauthorized here, get manager, get manager, get manager, and then it got a successful response here, right? So if you can follow this one, for instance, follow TCP stream, as you can see, get examples.html. This here is not found. Examples. Okay, you can scroll down. Okay, host. You can see get get manager. So get manager, right? So it's trying to enumerate different, but it did found a 200 response as we have seen. Get manager unauthorized. There's actually a get manager unauthorized, get manager unauthorized. There has to be a successful one because we have seen from the packet there's a successful, yeah, this one. Get manager slash image, for instance, it's a response. So this is most probably the name of the directory. So it's slash manager. Okay, question number 6. You're doing quickly. After accessing the admin panel, the attacker tried to brute force the login credential. Can you determine the correct username and password the attacker successfully used for login? So for this, you can use two different things. You can apply the post HTTP request post method, so you can see what kind of password or credential the user has given to the server, and also you can look for filters like HTTP dot autobasic, okay, and identify any kind of session Okay, or credentials. So as you can see, we have we have here a session, G session, a G session, and we can expect to see some credentials here. So what we can do, we can click here and look at the HTTP protocol. Okay, we can look down to authorization. As you can see, authorization basic, and we can see here the credentials that were submitted are admin and Tomcat. So admin is the username and Tomcat is the password. Okay, so that is indeed the answer, admin and Tomcat. Question number 7. Once inside the admin panel, the attacker attempted to upload a file within the intent of establishing a reverse shell. Can you identify the name of the malicious file that's covered? Okay, so since we know this packet is the packet where he submitted the credentials, we can just follow the TCP stream and look. So as you can see, this is this is the session. Okay, as you can see, we have content disposition. The file name here, as you can see, is jxq.word. Yeah, so this is the file name, and as you can see here, the response was 200. Okay, so he was successful in submitting the file. Okay. So question number 8, the final question. After successful establishing a reverse shell on our server, the attacker aimed to ensure persistence on the compromised machine. For the analysis can determine the specific command they are scheduled to run and maintain persistence or presence. So what we can do actually here, we can just, after he uploaded the file, what did he do? We can follow the TCP stream to see. So what did he do? Once he established the shell, he looked, who am I? Root, okay, and cd temp, the password, the tmp. And so this is the command or the reverse shell command that he has run, /bin/bash. So he's trying to establish connection on this port to this IP. So we can see, yeah, this is the command that the attacker used to establish a shell connection. So yeah, so yeah, this was about this lab. I hope you enjoyed the video. Just a quick lab for our forensics assessment. See you